This is a video for unknown A, and what's going to happen in this video is I'm going to take a solution that looks like this. Okay, it looks like a clear solution, but that solution could either have silver, barium, zinc, silver, barium, silver, zinc, barium, zinc, all three ions, or none of these ions. So it either have 0, 1, 2, or 3 ions right there. The procedure I'm going to follow is the same as on your flow chart, which is add Cl minus to the test tube. If there's a precipitate, mix it, and then if there's a precipitate, centrifuge and decant. Okay, in the solution, I would add FeCN6 minus 4. And again, I'd mix it, and if there is a precipitate, I centrifuge and decant. And to that solution, I add CrO4 minus 2. Ultimately, you're going to be, we'll look at this in a moment, but you're going to be answering yes or no to, on page 5, yes or no. Do I have Ag plus? Yes or no, do I have Ba plus 2? And yes or no, do I have Zn plus 2? You will also be giving supporting reasons behind that, and you can see the details for that in the general info video about unknowns. So you will need to watch that. So here are the tests we're going to show. I'm going to go big screen so you can see it for unknown letter A. All right, so I'm going to take this solution right here, and I'm going to add Cl minus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or 11 drops. I think that looks good. And I don't know if you can see that compared to a blank test tube, but a distinct difference. It's really cloudy that we can see that right there. I'm going to mix this around. Okay, and this one can, and then I'm going to centrifuge it. So we see that cloudiness. I'm mixing it. I'm centrifuging it. Now this centrifuge works because heavier things go to the outside. So that if there's a precipitate, it's heavier, it'll go to the outside, just like when you go to Valley Fair and you go on a spinning ride, you're heavier than the air. So it feels like you're getting this centrifugal force to the outside. I'm gonna try to spin this one pretty good. Sometimes I'm finding if I don't spin it long enough, I get some carryover into the next things. So I'm letting this go, spinning it really good. Okay. Now, ideally, I'd let it come to a stop, but I'm going to put my hands clearly away from the glass. I'm going to stop that, and hopefully that's separated well. Let's see how we did. Pretty good. Okay, so the solution looks pretty clear, and there's a solid on the bottom. If you can see that too well. And what I'm going to do is transfer it. Okay, sometimes you might have to recentrifuge or do that, but I think we're pretty good transferring it over. So there's a slight haze, but it's pretty small. It's pretty clear, this solution. And then what's left behind is the precipitate right there. So now I'm going to follow my flow chart, and the next thing it says to add is FeCN6 minus 4. So I'm going to add these drops, and probably the most important part is to look right when I add those, and we'll see what happens to this. So I added 10 drops, and I mix that, and I'm not really seeing any cloudiness when I add that. I guess I could centrifuge it, but there's no really cloudiness in the solution. So there is no need to do a centrifuge if there's no cloudiness present. Okay, now I'm going to go to the last step, adding CrO4 minus 2, and watch as I add the drops. I don't know if you can see that but it is significant cloudiness. Now, because I don't have to separate anything else, I could centrifuge it, but I really don't need to. I definitely see significant cloudiness and some yellow color as opposed to like a clear solution right there. So I see that cloudiness. I'll wrap that around and mix that right there. So that is unknown A. Again, that will help you fill out page 5. Use your chart on page 4 to fill out page 5. Make sure you're not only answering yes, no for each ion, but you're doing the supporting reasoning following that instructions I gave you in the general unknown instructions. Thank you for watching. Let me know if you have questions with this.